Okay, so from the 2019 AP exam, this is an AB free response, guys, but I'd like you to do it. The reason is I'm going to give you three of these. So I'm going to give you the AB number 5, and I'm going to also give you the BC number 5 and the BC number 6 from 2019. Okay, so I want you to look at three of these. Okay, this one, it's not on the AB test this year. This is one of the parts that they cut out of AB. Okay, but I really think it's a possibility that it could be on the exam this year for you guys. Okay. So it's just this region R, okay, and it's enclosed by the graphs of g is equal to -2 plus 3 cosine of pi over 2x, and then h of x is 6 minus 2 times the quantity x minus 1 squared, and the y-axis and the vertical line x equals 2, okay? So this one, right, this top part right here, let me get a pen. This top part, okay, is the parabola, okay? Um, because I know that that one, the x-intercept is going to be higher than this one, okay? Um, so when you put 0 in here, that's going to make 1. So it's going to be 4. 1, 2, 3, 4. So I know it's this one, not this one, okay? Because when it's 0 here, okay, you're going to cosine of this would become cosine of 0, and cosine of 0 would be 1. Or cosine of 0, yeah, cosine of 0 would be 1 times 3 is 3, and then with the -2 makes 1. So that'd be this one, okay? That's just a way to distinguish which one's which, okay? So I'm going to automatically write, okay, this one's is the h of x function, and this one right here is the g of x function. Okay, so the first question they ask you is what's the area, right? What's this area region R? So we're going to want to integrate from 0 to 2, and it's going to be top minus bottom, okay? So let me go to my paper and we'll do that. We'll work that one out. Okay, so the area of the region would equal the integral from 0 to 2 of h of x minus g of x, and then we could have parentheses around that, and then dx. Okay, so then this would equal the integral from 0 to 2. So h of x is the 6 minus 2. So 6 minus 2 parenthesis x minus 1 squared, and then minus the g of x, okay? And the g of x is -2 plus 3 cosine of pi over 2 x. Okay, so I'm going to close the parenthesis for the g of x, and I'm going to close the parenthesis for the subtraction of the two functions, and then dx. Okay, and I'm going to come over here. This would be equivalent to, we're going to need to clean this up a little bit, okay? This would be the integral from 0 to 2 of, okay, and I'm going to start writing this out. This would be 6 minus 2 times x minus 1 squared. This becomes plus 2 minus 3 cosine of pi over 2 x, and then dx, okay? And the 6 and this 2 we can combine. So that'd be the integral from 0 to 2, and 6 and 2 is 8. So it'd be 8 minus 2 times x minus 1 squared minus 3 cosine of pi over 2 x, and then dx. And you could put parentheses around this whole thing if you wanted to, or bracket, okay? I would do this as 3 integrals, okay? So this is equivalent to the integral from 0 to 2 of 8 dx. And then I'm going to bring out this -2. So it's going to be minus 2 times the integral from 0 to 2 of x minus 1 squared dx. And then I'm going to bring out this -3. So minus 3 times the integral from 0 to 2 of cosine of pi over 2 x, and then dx. And then these are going to be some simple integrals to do. Okay, some simple antiderivatives. I'm going to hold off. I'm going to do all the integration at once. Okay, if you did this one, because this one is ready to go right now. This one's not. Okay, well, I shouldn't say that. Some of you guys can do this in your head. Okay, but I would, just to make sure. Okay, I'm just cautious. All right, I'm going to let u be x minus 1, and then du would be dx. Okay. And then that's going to allow me to integrate this really easily. And this is I'm going to change these to u values, okay? And for this one, I'm going to you can't use u because you're using u for this one. So I'm going to let this one be w. And I'm going to let w be pi over 2 x. And then dw would be pi over 2 dx. Now I don't have the pi over 2, right? So I'm going to have to multiply by pi over 2 and also multiply by 2 over pi, okay, to get this. Okay, so then this first one is the integral from 0 to 2 of 8 dx, and then minus 2, the integral of, and it'd be u squared du, and then this would be from -1 to 1, okay? And then minus 3, and this one's going to need, I'm going to need to multiply by pi over 2 and 2 over pi. So this is going to be minus 6 over pi, the integral. And I'm in my mind, I'm gonna already have a pi over 2 here in my dx, and that's gonna make my dw because I already fixed it out here, right? And so this would be cosine of w and then dw. And so all I would need to do is switch these two w values, okay? So if I put 0 in here for x, the w value would be 0. And if I put 2 in here, that would give me pi. All right. Okay, so now we're ready to integrate, okay? So this would be 8x evaluated from 0 to 2 minus 2 times, and this would be u cubed over 3 evaluated from -1 to 1, and then minus 6 over pi. And okay, so the derivative of sine is cosine, so the integral of cosine would be sine, so this would be sine of w evaluated from 0 to pi, okay? So this would come out to be 8 times 2 minus 8 times 0. This would be minus 2. And this would be 1 cubed over 3, which would be 1/3. And then minus, okay, and this would be -1 cubed, right? So that would give you -1. So this is going to be plus 1/3 minus 6 pi times sine of pi minus sine of 0. Let's light that up a little bit. Okay, so this would be 16. This would be minus 2 times 2/3 minus, and you know what, I should say this right now. Right now, if you left your answer right here like this, it's the right answer, okay? All right. And then this one would be minus 6 over pi. And sine of pi would be 0, and sine of 0 is 0, so this would just be 0. So really all we're left with is 16 minus 4/3. Okay, and if you left your answer like that, that'd be fine. Okay, this is equivalent to 48/3 minus 4/3, which would give you 44/3 for an area. Okay, I'm going to slide that up so you can see it. Okay, I would take the time. Don't skip too many steps, just so you don't get things wrong. Okay, and again, remember, you don't have to simplify this. Okay, so if you stopped right here, you have the right answer. Okay, you've done all the calculus. Okay, all right, you have a right answer, and you'll get the answer point. Okay, because these are always worth points. Okay, All right, let's go to part B. Okay, so for part B, they're asking you the region R is the base of a solid. For the solid at each x cross section perpendicular to the x-axis has area A of x is equal to 1 over x plus 3. Find the volume of the solid. So this is area of cross-section areas, right? And so what happens is a lot of times we have to come up with the area function because they tell you it's an equilateral triangle or it's a rectangle or the height of the rectangle is so many times the width or whatever they might tell you, or it's a semicircle. And we have to come up with that area formula, okay? So for this problem, they gave us the area formula. The area is this is the formula 1 over x plus 3. That's the area formula. So if we take the area and multiply by the thicknesses of these little slices, right? Because this is a slice, okay? And we add all those slices up, we will have a volume of a solid, okay? So that's what we need to do. We need to integrate this from 0 to 2 and multiply it by dx, because this is going to be square units times the dx, which is the same unit, right? And we're going to get cubic units, which is volume. That's a volume unit, okay? So let's go to our paper and we'll do this. So for this one, the volume is going to equal the integral from 0 to 2, our area function, right, times dx. Because this is square units and this is the same units. So when we take square units multiplied by units, we get cubic units, okay, which is volume. That's what I was saying earlier, okay, in case you didn't catch on. Okay, so this is the integral from 0 to 2, and this area function right here is 1 over x plus 3 dx, okay? Now, I'm going to use integration by substitution. Some of you can do this mentally, and that's absolutely fine. I just like to be safe and play it safe and just I like to use u substitution just to make sure I don't miss a negative or something, okay? Because it'd be easy to do, okay? So u is equal to x plus 3, and then du would be equal to dx, okay? So that makes this equivalent to the integral of 1 over u du. Now I got to change these limits of integration to u values because right now they're x values. So if I put 0 in here for x, that would make my u value equivalent, or corresponding u value, be 3. And my corresponding u value for when x is 2 would be 5, okay? And then I know from this integral, that's an easy integral, right? It's just natural log of absolute value of u. And we're going to evaluate this from 3 to 5. So that would be the natural log of the absolute value of 5 minus the natural log of the absolute value of 3. But really, we don't need absolute value because 5 and 3 are both positive. So this is equivalent to the natural log of 5 minus the natural log of 3. Great answer. Even this one's a great answer, okay? Because right here, you could stop and you get all the points, okay? Right here, you stop and you get all the points. Now, there is another way you can write this, okay? So for future math classes, I think we should still go over this, okay? There's a logarithm property that says if you take the logarithm up with the same bases, which they are because they're base e here, natural log of 5 minus natural log of 3 is equivalent to the natural log of 5 over 3. So that would look like this, the natural log of 5 over 3, okay? And all of these would be the right answer, okay? Excuse me, didn't mean to sneeze. Okay, so now let's go to part C on our paper, okay? Okay, so for part C, they're asking you to write, but do not evaluate. So they don't take the time to evaluate this. They're trying to save you time, okay? An integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. So y equals 6. Now the top of my parabola is at 6, right? So that's right here, and it's going to be a horizontal line, right, going through that vertex right there. And it looks like this, right? That's the line y equals 6, and I'm rotating around this, right? Okay, so I always need to go draw my radiuses perpendicular to that, to the furthest one away, right? And that would be this bottom one, g of x. Okay, all right, so that would be my big R, and then my little radius is the one closest. So this, since I have a gap between the axis that I'm rotating around and the curve I'm integrating, right? That's going to be a washer method, okay? So I need to figure out my big R, okay? And the area of this would be pi r squared because I'm rotating this around, right? Making a circle. This area would be pi r squared, and I have to minus this one, right? Minus pi little r squared, okay? All right, so let's go to our paper and we'll write this one up. Okay, so for part C, I need to first figure out my big R, right? And my big R would be the top minus bottom. So the top would be 6 minus the bottom function, which is g of x. Okay, and that's equivalent to 6 minus, and my g of x function was that cosine function. So it's -2 plus 3 cosine of pi over 2 x. Okay, and then this big R becomes 6, and I would write plus 2 minus 3 cosine of pi over 2 x. Okay, and 6 and 2 can be combined, so that'd be 8 minus 3 cosine of pi over 2 x. Okay, so that's my big radius. Okay, now what's my little radius? My little radius would be equal to 6, because that's the top curve, minus my h of x function. So that's equivalent to 6 minus, and my h of x function was 6 minus 2 times x minus 1 squared. This becomes 6 minus 6 plus 2 times the quantity x minus 1 squared. 6 minus 6, those cancel, and you're left with 2 times the quantity x minus 1 squared, okay? So the volume of this, and we're going to make these discs starting at 0, and we're going to go all the way to 2. So the integral from 0 to 2, and it's going to be pi big R squared. Now, why? Because this is a cross-section area, right? And it's the area of the big circle, right? Minus the smaller circle, which is pi little r squared at the same x value, okay? And then dx, right? Okay, now what I'm going to do is I'm going to pull the pi out of all this. So this would be pi, the integral from 0 to 2, big R, right, which is this 8 minus 3 cosine. So I would write it like this, okay, parenthesis, 8 minus 3 cosine, parenthesis, pi over 2x, close the parenthesis for the cosine, close the parenthesis for the big R, and then I need to square it. And then minus my little r, okay? And my little r would be this 2 times x minus 1 squared, close the parenthesis for that. That's my little r, and I'm going to square it, and then dx. And you've got it. That's it. That's the answer, okay? All right, there's some things you could do to clean it up. I mean, you could square this and this make this to the 4th power, but I wouldn't even bother, okay? Because you've written it, okay? All right? Okay? And that's it, okay? That's it for this volume. Okay, I really think, I'm going to tell you, I think they're going to ask the BC students a area volume question somewhere on the exam, okay? I just think I just think they're going to this year. That's just my gut feeling, okay? Could be totally wrong, all right? But this measures whether you can integrate and you understand some basic things, okay? All right, so I want to assign this one, okay? So AB number 5, I don't think you guys have this question in your packet. So I just want you to download the PDF, okay, that I have on the assignment, and just take a look at that and just do it from that, okay? All right, you guys, let's go to our BC questions now, all right? So for the number 5 question on the BC exam from 2019, they tell you consider the family of functions where you have f of x is equal to 1 over x squared minus 2x plus k. K is a constant, okay? Find the value of k for k greater than 0 such that the slope of the line tangent to the graph of f at x equals 0 is equal to 6. Okay, so slope of the line tangent, that'd be f prime of 0, and that has to equal 6, okay? So let's go ahead and write this out and do it on our piece of paper. So what we know is that f of x is equal to 1 over x squared minus 2x minus 2x, whoops, not minus 2k, minus 2x plus k, okay? And by saying the slope of the line tangent to the graph of f at x equals 0 is equal to 6, that's telling you that f prime of 0 is equal to 6. And so what k value causes this to happen? Well, we're going to have to take the derivative of this, right? Okay, so I would rewrite this as f of x is equal to x squared minus 2x plus k, and raise that whole thing to the -1 power, because then you can just use the chain rule, okay? So f prime of x would equal, and then power down, so -1 times x squared minus 2x plus k, subtract 1 from the power, so that'd be -2, and then times, okay, the derivative of this, right? So the derivative of x squared would be 2x, minus the derivative of 2x would be 2, so minus 2. And then k is remember, k is a constant, so when you take the derivative of it, it's just going to be 0, okay? All right, so now, okay, this would be, okay, f prime of 0, and that'd be -1 times, and it would be 0 squared minus 2 times 0 plus the k raised to the -2 times 2 times 0 minus 2, okay? So that means f prime of 0 would equal -1, and then this would be 0, and this would be 0, so this would be k to the -2, so times k to the -2, and then this would be 0 minus 2, so it'd be times -2. Okay, so f prime of 0 would be -1 times -2, which is be 2 over k squared. So this would be 2 over k squared. Okay, so from this, we know that f prime of 0 is equal to 2 over k squared, but we also know it's equal to 6. So that would mean 2 over k squared, not x, but k squared is equal to 6. We could multiply both sides by k squared, and we get 2 is equal to 6 k squared. So that would mean k squared is equal to 2/6, which is equivalent to 1/3. And then, okay, so we would square root both sides, right? So the square root of k squared is equal to the square root of 1/3. So that would be k is equal to plus or minus 1 over the square root of 3. Now they tell you something, right? And they tell you that in part A that k has to be greater than 0. Okay, so which one do we pick? Well, it has to be k is equal to 1 over the square root of 3. And that's our answer, okay? You wouldn't have to box your answer, okay? But that's how you do number A, okay? Or letter A, okay? So let's go ahead and go to part B, okay? So for part B, and they say for k is equal to -8, find the value of 0 to 1 f of x dx. Okay, so they're telling you this k right here is going to be -8. So f of x is, in this case, going to be 1 over x squared minus 2x minus 8. Okay, and we want to integrate that from 0 to 1. Okay, so let's go to our paper. So they want us to find the integral from 0 to 1 of f of x dx. Okay, so in this situation, it'd be the integral from 0 to 1 of 1 over x squared minus 2x minus 8 dx, okay? So what does that mean? That means that we should look, you should recognize that this is factorable, right? It's gonna be x minus 4 and x plus 2. So this is equivalent to the integral from 0 to 1 of 1 over, and it'd be x minus 4 times x plus 2 dx. Okay, now to integrate this, we're going to have to use partial fraction decomposition. Okay, so I'm going to do that next. So 1 over x minus 4 times x plus 2 has to equal some number a over x minus 4 plus b over x plus 2. Okay, multiplying both sides by x minus 4 and x plus 2, we would get 1 is equal to a times x plus 2 plus b times x minus 4. Okay, so we're going to let x equal, let's let x equal 4 first. Okay, So if x equals 4, this would be 1 is equal to a times 4 plus 2, which would be 6, okay, plus, and then this would be b times 0, okay? So 1/6 would be your a value, okay? Now let's find the b value. We're going to do that by letting x equal -2. If x was -2, then this would be 1 is equal to a times 0 plus b times -6, okay? And so that would give you, this would be 0. So we'd have 1 over -6 would equal b, okay? So now I can break this integral, right? So the integral from 0 to 1 of f of x dx is equivalent to the integral from 0 to 1 of 1/6 over x minus 4, okay? And then because b is negative, this is going to be minus 1/6 over x plus 2, and then dx, okay? Now what I'm going to do is I'm going to pull a 1/6 out, okay? So this would be equal to 1/6, and I'm going to do this for each one. I'm going to do separate integrals here. You wouldn't have to, okay? So 1/6, the integral from 0 to 1 of 1 over x minus 4 dx minus 1/6, the integral from 0 to 1 of 1 over x plus 2 dx, okay? I'm gonna do a u substitution, and I'm gonna let u equal x minus 4, okay? And then over here, and then du, let's go ahead and do du. Du would be dx, right? Okay, and then over here, I'm gonna let x plus 2 be w, okay? And then dw would equal dx, okay? So that means this becomes 1/6 the integral of 1 over u du, and I'm going to change these values to u values. So 0 minus 4 would be -4, and then 1 minus 4 would be -3, and then minus 1/6 the integral of, okay, and these are going to be 1 over w dw, okay? And then this would becomes the integral from 2 to, putting 1 in here, that would be 3. Okay, now we know what the integral of 1 over u is, right? And 1 over w, that's just the natural log, okay? So this becomes 1/6 the natural log of the absolute value of u evaluated from -4 to -3, and then minus 1/6. I just realized you can't see it, okay? Minus 1/6, I should write just minus 1/6 the natural log of the absolute value of w evaluated from 2 to 3, okay? Now, when I put -3 in here, right, and evaluate it, that's just going to become 3, okay? So this is equal to 1/6 the natural log of 3 minus 1/6 the natural log of 4, okay? And that's those two. That's that one evaluated, and then minus, and then bracket, and then 1/6 the natural log of 3, minus 1/6 the natural log of 2, because absolute value of 2 is still 2. Okay, so now I'm going to distribute this minus right here. Okay, so we have 1/6 the natural log of 3 minus 1/6 the natural log of 4 minus 1/6 the natural log of 3 plus 1/6 the natural log of 2. Okay, so these two are going to cancel out, right? Because we have 1/6 natural log of 3 minus 1/6 natural log of 3. Okay, and 4, let me just go ahead and write this. So this would be 1/6 the natural log of 2 minus 1/6 the natural log of 4. And let me say something, okay? So right now, if you wrote your answer right now, right? Let me put a red marker here. Hold on, let me get a red pen. Okay, so what I was trying to say earlier is that if you stop right here, right where my little red asterisk is, okay, that's a correct answer. That's a numeric answer. You're done, okay? So you could stop right there. I'm going a little bit further, okay? So this 4 could be written as 2 squared, okay? So this is 1/6. I'm actually doing this for future math classes, okay? So 1/6, the natural log of 2 minus 1/6, the natural log of 2 squared. Now that square can come down, right? So this would be 1/6, the natural log of 2 minus 1/6 times 2, which is 2/6, the natural log of 2. And now you have natural log of 2, so you can combine these. This would make negative 1/6, the natural log of 2. And that would be your answer, okay? Okay, so the final simplified answer is negative 1/6 natural log of 2. I would stop right here where the asterisk is, okay? There's no point in you doing this because the only thing that could happen is you lose a point for the answer point, okay? I know I want you to do this, okay? But that's okay. For the AP exam, do what they want, not what I want, all right? Okay, let's go to part C. For part C, now they're telling you k is equal to 1, and they want you to integrate from 0 to 2 of f of x dx, or show that it diverges, okay? So we're going to take a look at this. So show that it diverges, that might make, that's kind of a hint. You may want to look at what could be wrong with this that would cause it to diverge, okay? So we're going to go ahead and look at this, okay? And we'll write on our paper. Okay, so we want to integrate 0 to 2 of f of x dx. Okay, so that's equivalent to the integral from 0 to 2 of, and remember our k is 1, so this is 1 over x squared minus 2x plus 1 dx. And once again, this one right here, that factors, right, into x minus 1 times x minus 1. So this is equal to the integral from 0 to 2 of 1 over x minus 1 squared dx. Now, there's a problem with this. There's a discontinuity. There's a discontinuity at 1, and that is in between my limits of integration. So I have a discontinuity between 0 and 2. It's happening at x equals 1, right? So we have a vertical asymptote for this function, okay? So that means, all right, we're going to have to integrate this, and we're going to have to do improper integrals, okay? All right, so we're going to have to break this up. We're going to have to break this up into, okay, the integral from 0 to 1 of 1 over x minus 1 squared dx plus the integral from 1 to 2 of 1 over x minus 1 squared dx, okay? And we can't put 1 in here, right? Because that's where the discontinuity happens. So we're breaking it up where the discontinuity happens, x equals 1, okay? So to do this integration, we have to look at a limit, okay? We have to look at the limit as, and I'm going to call this one b, okay? As b approaches 1, okay, so if we're going from 0 to 1, we're going to approach 1 from the left side, okay? So b approaches 1 from the left of the integral from 0 to b, okay? So we're replacing the 1 with b, and we're going to take a look and see what happens as this b gets really, really close to 1 from the left side, okay? Do we get a value or not, basically, okay? So this is 1 over x minus 1 squared dx. This one, it's going to be the lower limit, okay? So plus the limit as a approaches. Now, we're going to look at this one. We're going from 1 to 2, so we want to approach 1 from the right side. So we want this a to approach 1 from the right, from the positive side. And then it's going to be the integral from a to 2 of 1 over x minus 1 squared dx. Okay? Now, what I'm going to do is I'm going to let u equal x minus 1, okay? Because then I have 1 over u squared, okay? And then du would be dx, okay? And then what I'm going to have to change is the 0 to u values and the b to u values, okay? So this is equivalent to the limit as b approaches 1 from the left of 1 over u squared du plus, and you know what, I'm going to put the limits in here, okay? So 0 minus 1, so this becomes -1, and then this top limit becomes b minus 1, because we've got to change them to u values, and then plus the limit as a approaches 1 from the right of, and then this would be a minus 1, and this would be 2 minus 1, which is 1, of 1 over u squared du. Okay, this is u to the -2, right? Okay, so we're going to take a look at this, the limit as b approaches 1 from the left. So I'm going to kind of assume that we can do this in our head. So this would be u to the -2. So we'd add 1 to our power. So this would be, we add 1 to the -2, so that makes -1, and divide by that new power. So this becomes u to the -1 over -1. And then we're going to evaluate that from -1 to b minus 1. And then we're going to take a look at what happens to the limit as b approaches 1 from the left. And then plus the limit as a approaches 1 from the right of, and this is going to be the same thing, right? Because it's the same integral. So it'd be u to the -1 over -1. And then we're going to evaluate that one from a minus 1 to 1. Now, this is, okay, so we can bring this negative out here, right? And this becomes negative, okay, -1 over u. So I'm going to go ahead and write that. The limit as b approaches 1 from the left of -1 over u from -1 to b minus 1 plus the limit as a approaches 1 from the right of -1 over u evaluated from a minus 1 to 1. Okay, so this would be the limit as b approaches 1 from the left of, okay, now we're going to put b minus 1 in because that's the upper limit, right? So this would be -1 over b minus 1. You know what? I actually want it to be -1. Okay, so -1, it doesn't, that would be the same thing. It's going to be easier. You'll see in just a minute. Okay. And then minus, and then it'd be -1 divided by -1, right? Which would be +1. So that'd just be -1 plus the limit as a approaches 1 from the right of -1 over 1. That'd be -1. And then minus a negative, so that'd be plus 1 over a minus 1. Okay, so the only thing we can, b is getting closer and closer to 1. So this is just gonna stay -1, right? But if you look at this, okay, as b approaches 1 from the left, that'd be a little bit smaller than b, right? Or a little bit smaller than 1. So like 0.9. So, or 0.999, okay? If you have -1 on top and 0.999 for b in the bottom, right? This is going to be a negative value, but it's going to be really close to 0, right? But it's going to be negative, right? And we're having negative up here divided by a negative, which makes it a positive. This is going to come out as b goes to 1 from the left. This is going to come out to be positive infinity. So we have infinity minus the 1 plus, so really that's just infinity, right? Okay. And then here we have plus, and then it's going to be a -1. So I'm going to put -1 in parentheses. Okay. And this time we're getting closer to 1, but we're a little bit bigger than 1, right? We're a little bit larger than 1. So like 1.001. So if we do this 1.001 minus 1, that's going to be a number that's really close to 0, right? and we're taking a positive number divided by a number that's really close to 0, but it's positive, right? Because this a is a little bit bigger than 1, okay? And so this is going to become out to be plus infinity, all right? So this is really infinity, that's going to be infinity minus 2. That's going to be insignificant, right? The minus 1 here is going to be insignificant to these infinities. So it's just going to equal to infinity, which means, okay, this means that the integral from 0 to 2 of f of x dx diverges, because it would only converge if that came out to be a number, okay? And that's the BC exam question number 5 for part C, and that's it. We're done with that one, okay? So let's go on to number 6 for the BC exam. Okay, question 6 from the BC exam on the 2019 exam. They're giving you a function f, and it has derivatives of all orders for all real numbers x. Okay, a portion of the graph of f is shown. So this is the graph of f. Okay, along with the line tangent to the graph of f at x equals 0. So that would be this line right here, right? Because that would have to be the tangent line. And then selected derivatives of f at x equals 0 are given in the table above. Okay, so this is the second derivative of f at 0, and it'd be 3, and so on. Okay, this is the third derivative, and this is the fourth derivative. Okay, all right, so part A says write the third degree Taylor polynomial for f about x equals 0. Okay, so that's just Taylor polynomial, right? So we just got to know what a Taylor polynomial means. Okay, so let's go and let's do that. So for part A, they're asking you for a Taylor polynomial, okay, at 0 and a third degree, right? So that means we need to go up to the third power of x, okay? And so this would be, I'm going to write p sub 3, because that represents a Taylor polynomial of third degree or third order, okay, of x, okay? And that would always be, and this is just a generic, this is just a generic one, okay? It'd be f of 0 over 0 factorial, which we don't write, times x to the 0, which we don't write, okay? Because those would just be ones, okay? And then plus f prime of 0 over 1 factorial, but we're not going to write 1 factorial because it's just 1, times x to the first. Well, we can write that. We do need to write it, right? So times x. Okay, so that's a first degree, yeah, first degree, right? Taylor polynomial. We need to go to the third degree, right? So we need to go 2 more, okay? 2 more terms. So the next term would be f double prime of 0. Okay, now's when the factorials start kicking in, okay? So over 2 factorial x squared, okay? And then plus f triple prime of 0, okay, over 3 factorial x cubed. Now, this is the third degree Taylor polynomial in general. Okay, this is kind of in general, right? What's the specific one for this function, right? So, okay, so let's write p sub 3 of x, okay, and then that would equal, okay, and we would have f of 0. Well, how do you find f of 0? Well, we're going to need to use the graph, right? Because we don't have the 0th derivative, right? We have the second derivative. We don't even have the first derivative, okay? So f of 0, well, this is the graph of f. So at 0, it would have to be this value right here. That's on this curve, not the line, but this curve right here, right? So that value would be 3, okay? So f of 0 is 3, and then plus f prime of 0 times x. Okay, so f prime of 0, we don't have the first derivative, right? But we have the line tangent to it, right? Which whatever the slope is the first derivative at that value, whatever the slope is, right? So we look and we're going to go down 2 and to the right 1. Okay, so this tangent line has a slope of -2. That means f prime of 0 is -2, okay? So that means this is going to be -2 times x, okay? And then the second derivative at 0, we can start using the table, right? The second derivative, this is the n stands for the second derivative. It's going to be 3, right? The second derivative at 0 is 3, okay? So plus, I'm going to slide that down a little bit, okay? 3 over 2 factorial. Well, 2 factorial is 2 times 1, so that'd be 2, and then x squared. Okay, so that's a second degree Taylor polynomial, right? We need to go to the third degree, okay? And then f triple prime, Okay, so that'd be the third derivative would be negative 23 over 2. Okay, so plus, and this numerator is negative 23 over 2 over 3 factorial. Well, that'd be 3 times 2, or 6x cubed. Okay, we're going to clean this up a little bit, okay? So p sub 3 of x would equal 3, and then we'd write this as minus 2x, and then plus 3 halves x squared. Okay, and we're adding this negative, right? So it's really going to be minus, okay? And I would multiply the top and bottom by 2. On the top, the 2 would cancel. On the bottom, it'd become 12. So this becomes minus 23 over 12 x cubed. There's our third degree Taylor polynomial for f, okay? About x equals 0, okay? That's it for part A, okay? And I would guess that they would ask you questions like this because they're kind of leading you to the next step and they're kind of walking you through these. And I kind of find that they always do that on these Taylor polynomial questions. They kind of walk you through it, okay? Do this first thing, then use that to get something else, and use that to get something else, and so on, okay? Okay, so let's go to part B. So for part B, it says, let's just worry about one thing at a time, okay? So write the first 3 non-zero terms of the Maclaurin series for e to the x, okay? So the first 3 non-zero terms, okay? So let's do that. So we should know, we should have memorized, okay? E to the x, also you have a cheat sheet in front of you, probably, okay? E to the x is 1, okay? X to the 0 over 0 factorial, okay? And then plus, and then it'd be x, sorry, I just went blank, okay? Plus x squared over 2 factorial, okay? And those would be the first 3 non-zero terms, okay? All right? And so this becomes, we could rewrite this as 1 plus x plus, and this would become 1/2 x squared, okay? And that's the first 3 non-zero terms for e to the x, okay? Now let's go to the next part of this. For part B, the second part of part B is write the second degree Taylor polynomial for e to the x f of x about x equals 0. Okay, so we got to take, now we want a second degree, so we only, the highest power we want is x squared, right? So if we multiply and get something bigger than x squared, we're going to ignore it, right? Because we just want the x squared term. Okay, that's the highest power that we're going to want when we multiply what we got in this first part with what we have from part A. Okay. Okay, so e to the x times f of x could be represented by the Taylor polynomial. So we definitely need to put approximation. Don't put equals, okay? All right. And so I'm going to take the e to the x and I'm going to distribute with each term until I get a power higher than 2, okay? So I have this 1 times 3, and that would be 3. And then 1 times the negative 2x, and that'd be minus 2x. And then 1 times 3 halves x squared, that'd be 3 halves x squared. So plus 3 halves x squared. Now, if I do the 1 times this one, now I've gone too far, right? Because I just want a second degree, right? So I just want power of 2. Okay, so now I'm going to move over and distribute the x until I get to a power higher than 2, okay? So x times 3, 3x. So plus 3x. And then x times negative 2x, and that gives you negative 2x squared. So minus 2x squared. And then x times 3 halves x squared. Well, that would give you 3 halves x cubed, and we're not looking for that, right? We're just looking for a second degree one, okay? All right, so now we need to move over to this 1/2 x, right? I know I was doing these, but they're the same thing, right? So 1/2 x squared, right? So 1/2 x squared times 3, right? And that'd be plus 3 halves x squared. So plus 3 halves x squared, okay? And then if we take 1/2 x squared times negative 2x, that's going to give me x cubed. I'm just going to ignore that, right? We don't want that. We just want the highest power to be 2, okay? If you write these from lowest power to highest power, which you probably did, okay, that's how we normally write them. and you start multiplying, you know, once you get past that higher power, all the rest are going to be higher power. Okay. Now, this is perfectly fine. I would say they would count this as an answer. I am going to clean it up a little bit. Okay. So e to the x f of x can be approximated with this second degree Taylor polynomial. Okay. So the only constant we have is this 3, right? Okay. So we're going to write 3. And then the x terms is we have a negative 2x and we have a positive 3x, right? So that makes 1x, so plus x. And then we have a 3/2 x and another 3/2 x. That would make 6/2 x. I'm sorry, I'm saying x and I should be saying x squared. Let me rephrase that. 3/2 x squared plus 3/2 x squared. That would give you 6/2 x squared, and 6/2 is 3. So we have 3x squared, and then we have this minus 2x squared. That would give us plus x squared. Okay? And that's a second degree Taylor polynomial for e to the x f of x. Okay? All right? That's it. Let's go to part C. So we want to let h be the function defined by h of x is equal to the integral from 0 to x f of t dt. Use the Taylor polynomial found in part A to find an approximation for h of 1. Okay? So h of x is defined as the integral from 0 to x of f of t, and we're going to use that third degree Taylor polynomial from part A. Okay? Now, if you happen to get part A wrong, okay, and you use it properly here, they're going to give you the points, all the points for this. I mean, you're going to lose points for this one, right, for part A. But if you use an incorrect answer, like we need to use part A, right, and part A is wrong, if you use it correctly, they're going to give you full points. Okay, even if you're going to get the wrong answer because you're using it correctly, you understand what to do. You just made a mistake in part A. Okay, so I want to make that really clear to you. Okay, they're trying to find how much math you know, not to try to catch you on everything. Okay, all right, so let's go to part C. Okay, so they're telling you that h of x is equal to the integral from 0 to x of f of t dt. Okay, so that would mean, okay, h of x could be approximated with integrating that Taylor polynomial from part A, okay? So this would be equivalent to the integral from 0 to x. And we should be using an approximate because it's equal to the integral of f of t. This polynomial is an approximation for f of t. So this integral is going to be an approximation for h of x, okay? Okay, so what we got from part A was we're going to take the integral of, I'm going to put parentheses here, and it was 3 minus 2t, okay, plus 3/2 t squared, okay, because x represents where we stop integrating at, okay, and that's the input for h, but these have to be t's, right, because of f of t. Okay, so plus 3/2 t squared minus 23/12 t cubed. And I'm going to close my parenthesis and then dt. Okay, so that means h of x is approximate, and we're going to just start taking the integral, okay? So this would be 3t minus 2t squared over 2 plus 3/2 t cubed over 3 minus 23/12 times t to the 4th over 4. And then we're going to evaluate this from 0 to x, okay? So h of x, this brand new function, okay, can be approximated by using, and I'm going to use a parenthesis here, this would be 3x minus, and then this one, the 2's would cancel, right? And I'd be left with x squared. Here, the 3's would cancel, so I'd be left with plus 1/2 x squared, x cubed, okay? Nothing cancels here, right? Okay, so this is going to be, and then this becomes minus 23 over 48 x to the fourth, close the parenthesis, and then minus, and it would be 3 times 0 minus 0 squared plus 1/2 times 0 cubed minus 23 over 48 times 0 to the fourth power, close your parentheses, okay? Now, all of these are going to be 0, right? But you got to make sure you show them that you knew to put 0 in here, okay? So even if you wrote minus and then you put 0 here, that'd be okay, because that shows that you knew this was all going to be 0, okay? So h of x could simply be approximated with 3x minus x squared plus 1/2 x cubed minus 23 over 48 x to the fourth. And then they asked you to use this to find an approximation for h of 1, okay? All right, so h of 1 would be 3 times 1 minus 1 squared plus 1/2 times 1 cubed minus 23 over 48 times 1 to the fourth power. Okay, so that means h of 1, actually, I shouldn't put an equal here because this is an approximation for h of 1, right? Okay, so h of 1 would be 3 minus 1, which is 2, plus 1/2, because 1 cubed is 1, times 1/2 would be 1/2, and minus 23/48, right? Okay, so we need, okay, and I would stop there, okay? Actually, I would tell you the truth. Right here would be the approximation, and that'd be good enough, okay? All right, because you've showed you've plugged it in, okay? So this is a numeric answer that's correct, okay? So I'm gonna put a little asterisk there again, right? If you stopped right here, well, actually, on this one, if you stopped right here, you'd be right. If you stopped right here, you'd be right. Probably this one's a little bit, I mean, it's a little bit cleaner if we do stop right there, okay? That would, I'm sure you're gonna get a point for h of x, okay? And then you're gonna get a point for h of 1, I bet. Okay, so something like this, okay? And h of 1 could be written like this, it could be written like this, or a single value, okay? So what I'm gonna do is I'm gonna get a common denominator, okay? So we need 48, right? So 48 times 2 is 96. So this would be, okay, so this is equal to 96 over 48 plus 1. Oh, whoops, I need to get that to be 48s, right? I'd have to multiply this by 24 over 24, so plus 24 over 48, because that's 1/2, and then minus 23 over 48, okay? Now this would be 1 over 48 plus the 96 over 48. So a good approximation for h of 1 would be, okay, and it would be 97 over 48. Okay, and that's a good approximation for h of 1, and I think that was all they asked you to do in part C, okay? All right, let's go to part D. Part D is known that the Maclaurin series for h converges to h of x for all real numbers x. It is also known that the individual terms of the series for h of 1 alternate in sign and decrease in absolute value to 0. Use the alternating series error bound to show that the approximation found in part C differs from h of 1 by at most 0.45. So we're using the alternating series error bound, right? Okay. And so it's going to be the absolute value of the first of the next term, right? Okay, so let's go ahead and go to our paper and figure this out. So what we know is that we used a 4th degree Taylor polynomial here, or you can call it a Maclaurin one too, okay? So we know we used a 4th one. Okay, that came from this 3rd one, right? Okay, and it came from integrating this one, right? This 4th one came from integrating the 3rd one, right? So, okay, so what we know is that the absolute value of the Taylor polynomial, and it would be the 4th one, right, for h, at 1 minus h of 1. Okay, so this error, right? Because we use a fourth one, right? Because the fourth power, okay? That has to be less than or equal to the absolute value of, okay, so what's this? We use this one to get the last term, right? We need the next term, right? Okay, and because these are alternating, right? The next one's going to be positive, okay? And it's going to be okay, so this was the third derivative, right? So this was the fourth, we got to find the fourth derivative at 0 over 4 factorial times 1 to the fourth power. And I forgot, we got to integrate this. Sorry. We got to integrate this from 0 to x, okay? And this would be dt. And you know what? This should be t right here. T to the fourth. And then close the absolute value. Because this is the next term, okay? Remember the alternating series? You use the next term, okay? So the next term comes from integrating the t to the fourth term, right? Okay? All right. So that means that this error right here has to be less than or equal to, okay, so we got to find the fourth derivative at 0, okay? Well, the table told us that, right? It's 54, okay? So this is going to be the integral from 0 to x, and it should be the absolute value, okay? And this is 54 over 4 factorial, which is 4 times 3 times 2 times 1, right, which is 24. And then t to the fourth, and then dt. Okay, so when we integrate this, this would be less than or equal to 54 over 24 times t to the fifth over 5, okay? And we're going to evaluate this from 0 to x, okay? And then that would be less than or equal to 54, or, well, actually, let's simplify 54 over 24 because they're both even, right? So that'd be 27 over 12, okay? And that actually reduces more, right? Now, we don't have on the normal exam, we didn't have a calculator for this. Okay, so this would be 27 over 12. Sorry, you couldn't see it. 27 over 12 times t to the fifth over 5 evaluated from 0 to x. Okay. And then this x is going to turn out to be 1, okay? And so this can be reduced even more, okay? So 3, because they're both divisible by 3, so this would be 9 over 4 times, so that'd be 9 over 20. So this is less than or equal to 9 over 20 t to the fifth evaluated from 0 to x, okay? And that'd be less than or equal to 9 over 20 x to the fifth minus 0, right? And now we're going to put 1 in here. So that'd be less than or equal to 9 twentieths times 1 to the fifth, right? So it'd be less than 9 twentieths, okay? It'd be less than 9 twentieths. But what is 9 twentieths? Okay? So if you do long division, right? 9 goes in, or 20 goes into 9, right? Well, 9 goes into 20 4 times, right? 4 times 20 is 80. That'd be 100. Bring down the 0, right? 5.45. This is less than 0.45, okay? So we just showed that this is less, okay? This is equivalent to 0.45. So our error, the difference between the Taylor polynomial at 1 and h of 1, it has to be, that difference between them is less than, okay, 0.45, and we've established that, okay? All right, guys. So that's all we'd have to do, okay, for that one. Okay, guys, that's it for today. We did question number 5 from the AB exam, question 5 from the BC exam, and question 6 from the 2019 BC exam. And I'd like you to do all 3 of these, okay? All right? Okay. That's it for today, guys. You take care. No more lessons, no more anything until after the AP exam, until Wednesday. Okay. So I'll just be sending messages to you guys, just asking how you're doing. You know, if you need any help, if you want to ask me any questions, okay. I can do a Zoom session if you want to ask questions, and so you can see it like live instead of, it's really hard to type responses back and forth. Okay. Some of you are doing that, which I love. I appreciate that, but it's just a little bit easier if I just talk you through it. Okay, too, instead of trying to type math symbols into Remind and all of that. Okay. All right, you guys are going to do great. Okay. I know it. You guys are going to do great. You're going to nail this. All right. I can feel it. You guys are doing great. All right. Take care, guys. Bye.